And then we're going to kind of push this to its limits because this is the easiest version of this, or the most simple version is just having one constant velocity the entire time and saying, okay, make that into a rectangle and find its area. Can we go to slide 5? So on slide 5, I have a worked out example of this. And I guess the second part is a little bit new, which is that will ask you for the distance as well. And in this case, the distance and the displacement, they're the same magnitude number. One just has a direction and one doesn't. All right, but we saw this on worksheets before, on our first worksheet about distance and displacement, when as soon as something starts to change direction, then those two numbers stop being the same size. So if we go to slide 6, here we have a much more complex graph, because on slide 6 you've got something moving to the right and then to the left and then to the right again. And so if I were to ask you what's the displacement for this entire graph, we couldn't just do it with one rectangle, we'd have to do it with 3 rectangles. So the first rectangle would be at the beginning for the first 2 seconds, and the area of that rectangle would be positive 12, because the base is 2 and the height is 6. Y'all with me on that one? So then the second rectangle that we draw, this is why there's that asterisk in your notes, is because it's the rectangle created by the velocity time graph and the time axis. So when we say that the area under the curve, under has kind of a weird meaning. This is what that rectangle would look like for that second piece of motion. And then we have to think to ourselves, what is the base and what is the height of this rectangle? So the base is each interval is 1 second. So the base is 4 seconds. And then what is the height? -4 meters per second. So this is when my brain starts to hurt, because in geometry, it's very rare that we have a negative side length on a shape. Okay, but here, remember that negative sign just means that the object is moving to the left for this 4 seconds. And so when we're calculating the area of that blue rectangle, we'll multiply them just like any base and height. And then we get that the area of that blue rectangle is actually -16 meters. And that means that in 4 seconds, that person ended up 16 meters left of where they started. Questions about that? So then our last rectangle would have to be up there. And so it's got a base of 4 seconds, a height of positive 6 meters per second, and we multiply that, we get a positive 24 meters. So one version of this problem is we could ask you, what's the displacement between 0 seconds and 2 seconds? And then you would just be telling me about that red rectangle. Or if I asked you to go from 2 seconds to 6 seconds, you'd just be looking at that blue rectangle. And so even though this has 3 different types of motion, we might ask you to only pay attention to one duration of time. But if the question were, what's the total displacement? Then what we'd have to do is we'd have to add all of those displacements together. So the total displacement is a positive 20 meters. Because when we add up those positive areas and that negative area, and we retain all of their directions, then the total is positive 20. The distance is not just 20 meters though. Because if we're going to find the distance, what we need to do is we have to look at each chunk and we have to take the absolute value of that chunk. Okay, so we can't just take the final sum and take the absolute value there. We have to look at the 12 meters and take the absolute value of that, the 16 meters, take the absolute value of that, and the 24 meters and take an absolute value of that to find that our total distance traveled is 52 meters. Questions? So then if we were going to look at a specific time interval that intersected these different rectangles, let's say from 1 second to 8 seconds, then what we'd have to do is we'd have to draw new rectangles and find the areas of those before adding them together. So we just look at these rectangles before and after the time interval starts.